Let's talk about power of lens. This is a convex lens and it is bisected, and this is principal axis. If a ray of light comes parallel to the principal axis, then we know that it passes through a point of the principal axis which is called focus and is denoted by F. And in the same way, if we take another convex lens and if the ray of light comes parallel to the principal axis, it also passes through the focus. Have you noticed that I made a little differently in the second case than that of the first case? In second case, the converging capacity of the lens is less. It means in first case the angle of convergence is more, but in second case the angle of convergence is less. It means in case of first the converging capacity of lens is more, but in second case converging capacity of lens is less. In the same way, let's talk about this concave lens also. The ray of light coming parallel to the principal axis appears to be diverged from a point of principal axis after refraction. In another example of the concave lens, the ray of light coming parallel to the principal axis passes in the same way, but what I made here, it appears to be diverging from a point which is a little away than the previous point. It means in first case the diverging capacity of lens is more, but in second case the diverging capacity of lens is less. This way, what can we conclude? Power of lens can be defined this way: converging or diverging capacity of lens is called power of lens. Okay, let's go back to the same diagram. Now, what is seen in the first convex lens? Look at this first convex lens. The focal length is less, and in second focal length is more. If a lens has more converging capacity or more power, then its focal length is less, and if a lens has less power, then its focal length is more. In case of concave lens also the same thing. Focal length of the concave lens having high power is less, but focal length of the concave lens having low power is more. So we can define power of lens in another way also. Reciprocal of the focal length of the lens is called its power, and its formula can be written like this: power of lens P equal to 1 by F. Small f represents focal length and it is measured in meter. Power of lens is measured in diopter. It is SI unit. That's why focal length of the lens should be measured in meter. Now it's time to talk about 1 diopter power. What it is? Power of a lens is said to be 1 diopter if its focal length is 1 meter. Let's go through one numerical, then we'll be clear about the power of lens and its unit. A man is wearing a spectacle of power plus 5 diopter. What will be the power of the lens? What is given? Power of lens P is equal to plus 5 diopter. Plus 5 represents it is convex lens. If it was written minus, then we'll say that this is concave lens. For convex lens, power is taken as positive, and for concave lens, power is taken as negative, because convex lens has real focus, light passes through the focus, so its focal length is positive and then its power will also be positive. In case of concave lens, its focal length is negative because light doesn't pass through its focus. Its power is taken as negative. Okay, let's go forward. Focal length small f is equal to question mark. Now we can say we have P equal to 1 by F. In place of P I am writing 5D. Now F is equal to 1 upon 5D. This is equal to 0.2. If 1 is divided by 5, then we will get 0.2, and since diopter is SI unit, that's why the focal length comes in meter. Now I want to write this in centimeter. It is equal to 20 centimeter. We can write one sentence for our answer, that is focal length of the lens is 20 centimeter. Okay, now I want to stop it. We'll meet in another class.